Hello there, Year 10. So today we're going to discuss a brand new topic called simultaneous equations. And at the end of this discussion, it is expected that you will be able to solve simultaneous equations into unknowns by elimination or substitution. Okay, now let's talk about first, why are we talking about simultaneous equations? Okay, simultaneous equations are equations that are all true at the same time or for the same set of values or of the variables. So they have solutions that work for all the equations at the same time. So simultaneous equations are equations that involve the same variables. Okay, so that's the first requirement. They should have the same variables. And the solutions are values that work for all the equations at the same time. So we are talking about here two or more equations, okay? And we can use simultaneous equations to solve everyday problems when two or more situations are being compared. So for example, you could compare two car companies that have different daily charges and different mileage rates. Or you could also compare mobile phone contracts to find the cheapest deal depending on how long you keep the phone. So it could be that you simply want to solve a puzzle involving two or more quantities, two or more unknown quantities. For example, the sum of two numbers is 10 and the product is 24. What are the numbers? So these are some of the situations where we can use the simultaneous equations. Now, we will discuss first how to solve simultaneous equations by elimination. And in this example, we are talking about two linear equations. Well, again, let us review what do we mean again by a linear equation. How do we know if an equation is linear? Okay. You will know if equations are linear because in a linear equation, the highest exponent in a linear equation, the highest exponent of the variable is 1. Okay. And the graph of a linear equation, from the word itself, linear. Okay, so the graph is a straight line. Okay, so that's how you will know if you have a linear equation. So now we are going to have two linear equations. For example, we are going to solve these simultaneous equations. 2y is equal to 3x plus 4 and 2x is equal to negative 3y minus 7. Okay, so if you will notice, we have the same variables. In equation 1, we have y and x variable. In equation 2, we have x and y variable. So we're talking about the same variables. And if you will notice, the exponent, the highest exponent of any of these variables is only 1. Okay, so therefore, we are talking about here two linear equations. Now, how do we solve this simultaneous equation? First is we arrange the equations in such a way that the variables will be aligned with one another. Okay, so that would mean if we have 2y is equal to 3x plus 4, okay, we can write this as negative 3x plus 2y is equal to 4. Okay, so this is the first equation. Then we have, next is we have 2x. Then we will transfer the negative 3y. So this is going to be plus 3y is equal to negative 7. Okay, so as you can see, the x's are aligned with one another. The y's are also aligned with one another. Then step 2. In step 2, we multiply one or both the equations by a suitable number so that the two equations have the same coefficient for any of the variable. What do we mean by that? If you notice here, the numerical coefficient, okay, the numerical coefficient of in our first equation, the numerical coefficient is -3, numerical coefficient of x, and the numerical coefficient of the x of the other equation is 2. So they are not the same, right? And here, if you will notice, the numerical coefficient of y in the first equation is 2, and in the second equation, that is 3. So they are also not the same, okay? So what do we do is we make the equations to have numerical, the same numerical coefficient, even if it's just for x or just for y, as long as they are the same, okay? So as for me, what I would do is I would make the numerical coefficient of my x the same. So to do that, I will multiply my first equation. Of course, when we multiply, we need to make it both sides so that our equality will remain the same. So I will multiply the left side by 2, the left side of the equation by 2, and the right side of the equation by 2. And then for the second equation, I will multiply this by 3. Okay, why 3? Because if I will multiply 2 and 3 and -3, I will have -6. And 3 and 2, I will have 6. Okay, so numerically, they are the same. And again, if you multiply the left side by 3, you should also multiply the right side by 2. Okay, so that's what we mean by multiplying one or both the equations by a suitable number. Okay, so this now becomes 2 times -3x is -6x, and 2 times 2y is plus 4y equals 4 times 2 is 8. And next we have 3 times 2x is 6x plus 3 times 3y is equal to 9y equals -7 times 3, that's -21. Okay, so now numerically the numerical coefficients of our x are the same. Next, we add or subtract the equations to eliminate one variable. Okay, so if we have -6x and 6x, to eliminate the x, what we will do is we will add them, right? Because they have different sign. And -6x plus 6x, that is 0. And 4y plus 9y, that is 13y. And 8 plus -21, that is -13. Okay, then what do we do next? We solve the remaining variable in the new generated equation. So now we only have one variable, right? So therefore, we can divide both sides by 13 so that we can now solve for y, which is -1. So now we already know y. Now, let us try to solve for x. We are going to work out the other variable by substituting the solved variable, which is this one, the y, to any of the original equation. So you will now have to choose where to substitute y. Is it here at 2y is equal to 3x plus 4, or 2x equal to -3y minus 7? Okay, So let us substitute y to 2y is equal to 3x plus 4. So therefore, this is now going to be 2 times negative 1 is equal to 3x plus 4. And this is equal to negative 2 equals to 3x plus 4. Or that is negative 2 minus 4 is equal to 3x. Or that's negative 6 is equal to 3x. Or that is x is equal to negative 2. So now, we now know the values of y and x. Okay, now you can check that. Let us try to check if our answer is correct. So to check, we are going to substitute y and x. So that is y is equal to negative 1, x is equal to negative 2 to both of the equations. And we need to make the equations true, okay, if we substitute them. So let's try the first one. We have 2 times negative 1. Is it equal to 3 times negative 2 plus 4? Let's see. This is negative 2. Is it equal to negative 6 plus 4? So that's negative 2. Yes, it is equal to negative 2. So we are true for the first equation. Now let's try for the second equation. So we have 2 times negative 2 is equal to negative 3 times negative 1 minus 7. Are they equal? Let's see. 2 times negative 2 is negative 4. Is it equal to positive 4 positive 3? I'm sorry, that's positive 3. Positive 3 minus 7. So we have here negative 4. 3 minus 7 is negative 4. So they are equal. So since in both of the equations, they are true, so therefore our answers are correct. X is equal to negative 2 and y is equal to negative 1. All right. Now, how do we really verify? Why is it that this is true? Okay. Now, let me just show you what happens whenever we solve simultaneous equations. Okay, just let me open my decimals. Okay. Oh, let me share my screen. Okay, so let us try to graph our equations. Again, let's go back to our given. In our given, we have 2y is equal to 3x plus 4. Let us try to graph it here. So we have 2y is equal to 3x plus 4. So as I have told you earlier, this is a linear equation, right? And when we graph a linear equation, the graph is a straight line. So this is the graph of our 2y is equal to 3x plus 4. If you will notice, the x-intercept is negative 1.3330, and the y-intercept is 0, 2. Okay, now let us graph the other linear equation. The graph, we have 2x is equal to negative 3y minus 7. So we have here 2x is equal to negative 3y minus 7. So the blue one is the other linear equation, right? And again, it is a linear equation. That's why when we graph it, it is a straight line. And if you notice, the x-intercept is negative 3.50 and the y-intercept is 0, negative 2.333. But what is this one? Okay, this point is where the two equations intersect. Remember, the green one is 2y is equal to 3x plus 4, and the blue one is 2x is equal to negative 3y minus 7. And what is their point of intersection? The point of intersection is negative 2, negative 1. Meaning, when they intersect, this is the point where they intersect. Negative 2 is the x value, and the y value is negative 1. And have we seen these numbers before? Yes. Those are the values that we got when we did the elimination. Okay? So as you can see, when we do the elimination, what we really get is the point of intersection of these two linear equations. And if you also notice, the point of intersection is unique. Okay? There is no other point of intersection for the two lines. It is unique. It is only one point. Okay? So it means we only have one solution. We have one unique solution for these two linear equations. Okay? So isn't it wonderful? You see, I hope you could see the connection between the graph and the algebraic manipulation that we did earlier, which is called process of elimination. All right, now let's try to solve another one. Okay. As you notice, this looks like quite difficult, right? Now, don't be afraid if you will see fractional forms, okay? So let us name this equation as equation 1, and let's name this as equation 2. Okay, so for equation 1, let us simplify. So this is going to be x minus 1 is equal to 3 multiplied to y minus 2. Okay, so we have x minus 1 is equal to 3y minus 6, or that would be x minus 3y is equal to negative 6 plus 1, or that is x minus 3y is equal to negative 5. Okay, so we just transform, okay, into a simpler algebraic equation, the equation 1. Now let's try to do the same in equation 2. So we have x plus 6 is equal to 4 multiplied to y minus 1. So we have x plus 6 is equal to 4y minus 4, or that is x minus 4y is equal to negative 4 minus 6, or that is x minus 4y is equal to negative 10. Okay. Now, let us now align our first equation and the second equation. So again, our first equation is x minus 3y is equal to negative 5. Our second equation is x minus 4y is equal to negative 10. Now, does any of our variables have the same numerical coefficient? Again, what are the variables we have here? We have x and y, right? And if you will notice, the x in equation 1 has a numerical coefficient 1, right? And the x in equation 2 has also numerical coefficient 1. Okay, so now since they have, both of them have the same numerical coefficient, then we can now either subtract or add. And if you notice, if we add them, we really do not eliminate them, right? So what we do is we're going to subtract. because x minus x is going to be 0. And negative 3y minus negative 4y is equal to y. And this is equal to negative 5 minus negative 10. That is going to be 5. So therefore, the value of our y is equal to 5. Now, we are going to substitute this to any of the equation to solve for x. So you can substitute it either at equation 1 or at equation 2. As for me, I will substitute this to equation 1 because here we have smaller number, okay? 3 is smaller than 4, right? So we substitute y to equation 1, and then we are going to solve for x. Okay, so substituting our y from this equation, so that's going to be x minus 3 multiplied to 5 is equal to negative 5. So we're going to have x minus 15 is equal to negative 5. Or x is equal to negative 5 plus 15. Or x is equal to 10. So there you go. We now have the values of y and x. Now let us check if these values will make both of the equations true. So let us check. So let us try to substitute x and y in the first equation. So we have here, let's write first the equation. X minus 1 over y minus 2 is equal to 3. So let's substitute x. So we have 10 minus 1 over our y is 5 minus 2. Is this equal to 3? So this is 9 over 3. Is it equal to 3? Yes. 9 divided by 3 is 3. So it is equal to 3. Okay. Don't stop because you need also to show if it is true also for the second equation. So we have x plus 6 over y minus 1 is equal to 4. So let's substitute. Our x is 10. So this is 10 plus 6. And our y is 5 minus 1. Is it equal to 4? So we have 16 over 4. Is it equal to 4? 16 divided by 4 is 4. Yes, so therefore, it is equal to 4. So therefore, our answers are correct. Okay, our solution is therefore, the solution is x is equal to 10 and y is equal to 5. All right. Now, let us try to solve the equations, the simultaneous equations by substitution. Okay. So again, let us use our first example. The 2y is equal to 3x plus 4, and 2x is equal to negative 3y minus 7. You know, in mathematics, we have lots of ways of doing things. So this is just one of those things, right? That we can solve by using different methods. Okay, so this method is by the substitution method. What's the first step? We make x or y the subject in the linear equation. What do we mean by that? We will try to solve for either X or Y, whatever your decision is, it's really up to you, okay? In any of the equations. So for example, again, this is my, oops, let me use a different color. So this is my first equation, and this is my second equation. So let's try to solve for Y in the first equation. So that would be, let us write first the given, 2y plus 3x. It is equal to 3x plus 4. Since we are solving for y, meaning we have to isolate y. So we divide both sides by 2 so that we can isolate y in one side of the equation. So this is going to be equal to 3x plus 4 all over 2. Okay. Now, step 2 is we substitute into the other equation. So we are going to substitute this to equation 2. So that will be substitute y to equation 2. So we now have 2x is equal to negative 3 multiplied to our y is now 3x plus 4 over 2 minus 7. Okay, and afterwards, we are going to solve for the value of x. Okay, so this is now going to be 2x is equal to negative 9x minus 12 all over 2 minus 7. Okay, so let us simplify further. We can multiply both sides by 2 so that we can remove our denominator. Okay, so that it will be easier for us to manipulate. So we have 2 times 2x, so that is 4x is equal to 2 times negative 9x minus 12 all over 2. So we can now cancel 2 here. So that's going to be negative 9x minus 12. And 2 times negative 7 is going to be negative 40. So you see, this is now more manageable, right? And we are solving for x. Don't forget that because we now only have one variable to solve. So this is now 9x plus 4x is equal to negative 26. And 9x plus 4x is 13x. And this is equal to negative 26. To solve for x, we divide both sides by 13. So therefore, x is equal to negative 2. All right, so therefore, now that we have solved for negative 2, we are now going to solve for, we have solved for x equal to negative 2, we are now going to solve for y. And to do that, we can substitute x to any of the equation. So let's try substitute x in equation 2, and then thus we are now going to solve for y. So therefore, we are going to have 2 times negative 2 is equal to negative 3y minus 7. So this is equal to negative 4 is equal to negative 3y minus 7. Or 3y is equal to negative 3. Divide both sides by 3. So this now becomes y is equal to negative 1. Did we get the same answer from our, from the first method that we did? So we have here x is negative 2, y is equal to negative 1. Let's check our answer in the There you go. So we have here x is negative 2, y is equal to negative 1. So if you notice, even though we did different method, we are going to come up with the same answer. Because as I have said before, the solution is unique. As you have seen in our graph, right? The solution is unique. Okay, now let us try to solve our second example using the method of substitution. Okay, so again, for example, this is equation 1 and this is equation 2. So let us try to simplify first equation 1. So we have x minus 1 is equal to 3 multiplied to y minus 2. So we have x minus 1 is equal to 3y minus 6. And since this is a method of substitution, we will isolate one variable. Okay, so in this case, it is much easier to isolate x. So we have here x is equal to 3y minus 6 plus 1, or x is equal to 3y minus 5. And now we have successfully isolated x. So we will now substitute x to equation 2. So we substitute x in equation 2. So therefore, if our equation 2 is x plus 6 over y minus 1 is equal to 4, so we are going to substitute the value of x in this equation. So we have 3y minus 5. Take note, this is our x. So this is x plus 6 over y minus 1 is equal to 4. And if you will notice, we now only have one variable, and that is y. So we have 3y minus 5 plus 6 is equal to 4 multiplied to y minus 1. Or that is 3y plus 1 is equal to 4y minus 4. Or this is 1 plus 4 is equal to 4y minus 3y. Or this is equal to 5 and this is equal to y. So therefore, our y is equal to 5. Okay? Now, what we're going to do now is we are going to substitute y in either equation 1 or equation 2. Okay, now let us try to substitute y in equation 1. So we have x minus 1 over, let us try to write first our first equation. So we have x minus 1 over our y is 5. So this is 5 minus 2 is equal to 3. Or this is equal to x minus 1 all over 3 is equal to 3. Or that is x minus 1 is equal to 9. Or that is x is equal to 10. So the value of our x is 10, while the value of our y is 5. Let us try to check if this is the same with what we got earlier. All right, so you see, the value of x here is 10 and the value of y here is 5. Okay, as you can see, even though we use a different method, we will get the same answer. Okay. Now, how about if we have this one? Okay, in this case, our first equation, what's the highest exponent in our first equation? The highest exponent is 1, right? So our first equation is a linear equation. While in our second equation, what is the highest? The highest exponent in our second equation. The highest exponent is 2, right? So therefore, this is not a linear equation, but instead, this is a quadratic equation. Okay, so if you have this one, it would be much faster or much easier to solve this using substitution. Okay, so from equation 1, so you will now decide if you will solve for x, if you will isolate x, or if you will isolate y. Okay, so let's try to isolate y. Okay. From 1, we are going to have, let us copy it. So y is equal to 4 minus x. And then we substitute y to equation 2. So therefore, we have, let's try to write first the equation 2. And we are now going to substitute the value of y here. So we have 4 minus x squared is equal to 4x plus 5. Okay, so we now have to square this binomial. Okay, so this is going to be 4 squared minus 2 times 4 times x plus negative x squared is equal to 4x plus 5. Okay, how did we get this? If you remember your special products and factoring, a minus b squared is equal to a squared, the first term, you square that, minus 2 times the first term times the second term, and this is plus b squared. Now, if you don't remember that, don't have to remember everything, you can just expand this into 4 minus x multiplied to 4 minus x, okay, and distribute each of the binomial to the second binomial. So that would be 4 multiplied to 4 minus x, and that is minus x multiplied to 4 minus x. Okay, now let's try to solve this one. So this is 16 minus 8x plus x squared is equal to 4x plus 5. Now let's try to solve this one. This is 16 minus 4x minus 4x plus x squared. So that is 16 minus x plus x squared. So as you can see, they are the same. Okay, now let us now simplify. So we have x squared minus 8x minus 4x plus 16 minus 5 is equal to 0. So let us lump them all in one side. So we have x squared minus 12x plus 11 is equal to 0. Okay, so now what do you notice? So we can factorize this, right? Again, how do we factorize? We look at the constant. So we have here, our constant is 11. So we are going to look for factors of positive 11 such that the sum is negative 12. So we can have 11 multiplied to 1 or negative 11 multiplied to negative 1. They are both positive 11. And if we will get the sum, this is 11 plus 1 is equal to 12. And this is negative 11 plus negative 1, that is equal to negative 12. So this is negative 12. Oops, that's negative 12x. Sorry, I forgot the x. That is negative 12, and this is also negative 12. So therefore, these are the factors that we need. So if we factor this, we have x minus 11 multiplied to x minus 1 is equal to 0. Okay, so we have two values of x. So our first value is x minus 11 is equal to 0. And the other one is x minus 1 is equal to 0. So our first value of x is equal to 11. And the second value is x is equal to 1. Now, if x is equal to 11, then therefore we are also going to have two values for y. So let's try to substitute this in equation 1. So from equation 1, we can have 11 plus y is equal to 4, or that is y is equal to negative 7. And then if x is equal to, what's the other one? 1, then again, from equation 1, we have 1 plus y is equal to 4, or y is equal to 3. Okay, so therefore, our solutions are x is equal to 11, y is equal to negative 7, and x is equal to 1, and y is equal to 3. Okay, so we have two solutions in this given. Okay, now why are we having these two solutions? Let's try to graph. Okay, so let me erase these two graphs. So again, what's the first equation? We have x plus y is equal to 4. So we have x plus y is equal to 4. Again, this is a linear equation, right? So it is expected that the graph should be a straight line. And if you notice, the y-intercept is 0, 4, and the x-intercept is 4, 0. Now, what's the other one? We have y squared is equal to 4x plus 5. So we have y squared is equal to 4x plus 5. So as you can see, we have this graph. You know what this graph is called? This is what we call the parabola. Okay. Now, what do you notice about the parabola and the line? Did they meet? Did they intersect? Yes, as you can see, they did intersect. And at how many points did they intersect? So they intersect at this point and at this point. Okay, now let us try to examine the points of intersection. What is this point? This point is 1, 3. In other words, the value of x here is 1 and the value of y is 3. And in this one, the value is 11, negative 7. In other words, the value of x here is 11 and the other is negative 7. Again, this is 1, 3. Let us try to check our solution. So there, can you see? One of our solutions is x is equal to 1 and y is equal to 3. That is 1, 3. And what's the other point of intersection? The other point of intersection is 11, negative 7. And what's our solution? There you go. The other solution is x is 11 and y is negative 7. All right? So as you can see, even though we graph them or we do algebraic manipulation using substitution, we will arrive at the same solutions. Okay. Oops. Now, sorry. Okay. Now let's try to solve another. Let's try to solve the following simultaneous equations. So we have here two linear equations, right? So we have x equal to 1 minus 2y and 2x equal to 5y plus 29. So you can see the highest exponent is just 1. Can you try to solve this on your own? So what's the first step? Okay, let's try. So first, we align the variables, right? So we write x equals 1 minus 2y to x plus 2y is equal to 1. And 2x minus 5y is equal to 29. So that our variables will be aligned with one another. Then we multiplied the first equation. We multiplied the first equation by 2. And that made it equal to 2x plus 4y is equal to 2. Why did we do that? So that the numerical coefficients of x would be the same. Then what do we do next? We subtracted, right? So that when we subtracted them, 2x minus 2x now becomes 0. And 4y minus negative 5y is 9y. And 2 minus 29 is equal to negative 27. Then we can now solve for y, which is equal to negative 3. Then what do we do next? We substitute this to any of the equation. So we substitute y. Let's, for example, we substitute it to x plus 2y is equal to 1. Or here, x is equal to 1 minus 2y. So we have x is equal to 1 minus 2y. So we substitute y, so that is x is equal to 1 minus 2 multiplied to negative 2. And this will give us 1 plus 6. That's our y. X is equal to 7. Now again, don't forget to check. If you don't feel confident with your answer, you can always check. So again, our solution is x is equal to 7, y is equal to negative 3. Okay, so substitute that to the first equation. We have 7 is equal to 1 minus 2 multiplied to negative 3. Would they be equal? So 7, is it equal to 1 plus 6? Yes, it is equal. How about in the other equation? We have 2 times 7 is equal to 5 multiplied to negative 3 plus 29. So we have 14. Are they equal? Is it equal to negative 15 plus 29? So yes, they are equal. How about this one? So in this case, we have a linear, let me write using different color. So this is a linear equation, and this one, I'll show you later what the graph looked like. Okay, so, but definitely this is not a linear equation, right? Now what do we do? What's the first step? Okay, so we isolate x in our first equation, right? So we solve for x, which is x is equal to 1 minus 2y. Then what do? We substitute x in our second equation. So we now have y1 minus 2y quantity squared plus y squared is equal to 10. Then what do we do next? We expand the binomial, right? So we expand this into this. Okay, then we simplify everything, right? So we have 5y squared minus 4y minus 9 is equal to 0. Okay. And thus, we are going to factorize it this way. Now, you can use the method that we discussed before, okay? Or if you really cannot remember those methods or those strategies, you can always use the quadratic formula, right? Again, the quadratic formula is x, in this case, y. We are not going to use x because the given is y. So the quadratic formula is, we have y is equal to negative b plus or minus square root of b squared minus 4ac over 2a. Okay, and in this case, our a is 5, our b is negative 4, and our c is negative 9. So we have negative of negative 4 plus or minus negative 4 squared minus 4 multiplied to a multiplied to c. So all over 2 times 5. That is our 2a. So we now have 4 plus or minus 16. And we have 4, negative 4 times 5 times negative 9 will give us positive 180 all over 10. And that is equal to, let me continue here, 4 plus or minus 196 over 10. And what is the square root of 196? The square root of 196 is 14, right? So that's 4 plus minus 14 all over 10. We now have two possible values of y, right? So we have y is equal to 4 plus 14 over 10. So that's the first possible value. And for the second possible value would be 4 minus 14 over 10. 4 plus 14 over 10 is 18 over 10. Or that is 9 over 5. 4 minus 14 over 10 is negative 10 over 10. Or that is equal to negative 1. Okay, so we now have two values for y. So you can see y is equal to negative 1 and y is equal to 9 over 5. And if we are going to substitute negative 1 in the first equation, we are going to have, let me write it here. So we have x plus negative 2 equals 1, right? Let me write it here. If we substitute y to the, negative 1 to the first equation, so we have x plus 2 times negative 1 is equal to 1. Or that is x minus 2 is equal to 1. Or that would be x is equal to 3. That's how we got 3 here. And if we substitute 9 over 5 to the first equation, so we have x plus 2 times 9 over 5 is equal to 1. Or that is x plus 18 over 5 is equal to 1. Or that is going to be negative 13 over 5. And that's how that's what we also got here. Okay? Now, I want you to get your paper and try to solve this. So we have 1, 2, 3, 4, 5, and 6. Try to solve all of this on your own. Okay, and this one also is y is equal to x plus 2, y squared is equal to 4x plus 5. Okay. Oh, I forgot. I told you earlier that I will show you what this graph looks like, right? So let's go to our decimals. Okay, let us remove the... Okay, what's the first? We have x plus 2y is equal to 1. Okay, this is a linear equation, so what do we expect the graph would look like? So that is x plus 2y is equal to 1. There you go. So the graph is a straight line because it is a linear equation. How about this one? X squared plus y squared is equal to 10. So we have here x squared plus y squared is equal to 10. So you see that is an equation of a circle. Okay. And what is the radius? The center is at 0, 0. This circle has a center at 0, 0. And what is the radius? The radius is this one. Okay, 3.162 actually is the square root of 10. And what do you notice between the circle and our linear equation? Did they intersect? Yes. At how many points did they intersect? They intersected at 2 points. And if you'll notice, the point of intersections are, the first one is 3, negative 1. So that would mean the value of x is 3 and the value of y is negative 1. And what did we got? There you go. We have 3, negative 1. Okay, how about the other point? This one is negative 2.6 and 1.8. So we have negative 2.6 and 1.8. Okay? So we are consistent, right? Graphically or algebraically. So again, please do this, work on your own. Okay, try to solve of these simultaneous equations. And submit that in our Google Classroom. And also this one. Submit that in our Google Classroom. But I would like to solve number 9. So here are the equations of 3 lines. So we have 3 linear equations. And the question is, do all 3 lines meet at a common point? So we are going to prove. So to prove that, we are going to solve our simultaneous equations. So let us denote this as equation 1. This is equation 2. And this is equation 3. So for equation 1, let us simplify this. So we have y is equal to 1/2 x plus 11. Let us multiply both sides by 2 so that we can remove the denominator. So therefore, this is now 2y is equal to 1/2 x times 2 is x. And 11 times 2 is 22. And then let us arrange the variables. So we have negative x plus 2y is equal to 22. Now for the equation 2, we have y is equal to 1/3 x plus 14. So we multiply both sides by 3 to remove the denominator. Because again, it's much easier to navigate around quantities with no denominator. So 3 times y is 3y. 1/3 x multiplied to 3 is x. And 14 times 3 is what? 42. And then we arrange our variables. So this is negative 3x plus 3y is equal to 42. So that's now our equations 1 and 2. Okay. Now looking at equations 1 and 2, if you'll notice, we have the same numerical coefficients. Again, let us write them. We have equation 1 is negative x plus 2y is equal to 22. And our equation 2 is negative x plus 3y is equal to 42. Now, do we add or do we subtract? Again, we need to eliminate one variable. So if we are eliminating one variable, we are going to subtract. Because negative x minus negative x is 0. And so 2y minus 3y is negative y. And 22 minus 42 is negative 20. Or that would be y is equal to 20. So we now have the value of y. And let us now, so we got now the value of y, which is equal to 20. Now we need to solve for the value of x. So we can now substitute y to any of the equation, or first or second equation. It's really up to you. Let's try to substitute y in, let's try to use equation 1. So in equation, in equation 1. So we have 20, that is our y, And we have 1/2 x plus 11. So we're going now to solve for x. So we multiply both sides by 2. So we have 40 is equal to x plus 22. Or that would be x is equal to, what is 42 minus 22? So we have x is equal to 42 minus 22 that is equal to 18. Okay, so we have x is equal to 18 and y is equal to 20. Now, we have another equation, right? We have a third line. So how do we prove that they meet at common point? So we are going to substitute the x and the y in equation 3 to prove if they will meet at the common point. Substitute x equal to 18 and y is equal to 20 in equation 3. So our equation 3 is y is equal to 2x minus 16 and y is 20. Is it equal to 2 times 18 minus 16? So this is 20. This is equal to 36 minus 16. And 36 minus 16 is 20. So they are equal. So we now have proof, therefore, since the value of x is equal to 18 and y is equal to 20 is consistent with all of the equations, so therefore the three lines meet at a common point. So there you go. Let's see if we got the same answer. So y is equal to 20. There you go. And x is equal to 18. So the lines do all meet. Let us check. Okay. Won't have to check that in a graph. Right? So, let's remove the, okay, so we have, oops, here's my slide. There we go. So we have here y is equal to 1/2 x plus 11. Let's enter that. Y is equal to 1/2 x plus 11. Oh, where is it? Oh, there you go. And the other one is y is equal to 1/3 x plus 14. So y is equal to 1/3 x plus 14. Okay, so it's the black line. And we have y is equal to 2x minus 16. Y is equal to 2x minus 16. So let's see. As you can see, the three lines meet at one point, and that one point is 18, 20. That would mean the x value is 18 and the y value is 20. And that's what we also got. All right. So again, we solve this number 7, number 8, and numbers 1 to 6. Okay. And submit that in our Google Classroom. Okay. So I will wait for your submission. Bye.